Ignition sequence starts.
Good morning, and welcome to this view of the International Space Station Flight Control Room located at NASA's Johnson Space Center in Houston. This is where a team of specialists is always on duty to monitor space station systems and assist the Expedition 66 crew members as they work through their daily tasks. Commander Anton Shkaplerov and his American, Russian, and German crewmates spent time this week preparing for a spacewalk, servicing communications gear, and supporting scientific experiment operations in the station's laboratories.
Houston Station on Space to Ground.
Welcome to Space to Ground. I'm Kayla LaFrance. It was an exciting week aboard the space station as the orbiting laboratory grew and the crew went for a walk outside.
And liftoff.
After its successful launch last Wednesday from the Baikonur Cosmodrome in Kazakhstan, the new Prishal docking module arrived safely to orbit and rendezvoused with the station on Friday. Prishal is a Russian node module that supports 6 docking ports, one of which was used to autonomously dock with Nyoka's Earth-facing port, which itself was attached to the orbiting laboratory back in July 2021. The spherical module carried with it 2,200 pounds of cargo and will add roughly 494 cubic feet of volume to the station. This week, NASA astronauts Kayla Barron and Tom Marshburn went for a stroll outside the orbiting laboratory to replace one of the station's S-band antenna support assemblies. Marking NASA's 78th EVA in support of the space station, the duo worked together as they ventured outside to remove the failed communication unit on the P1 truss and to install a new replacement. Fellow crew members Raja Chari and Mark Vandehei were on duty throughout the day, monitoring the 2 astronauts during the spacewalk and helping them in and out of their spacesuits. Matthias Maurer was also on hand as he controlled the Canadarm2 robotic arm, assisting the spacewalkers at the Port 1 truss structure worksite. Speaking of spacewalks, science inside the space station is studying a new technology that could keep astronauts and equipment cool while working outside the orbiting laboratory. The Spacesuit Evaporation Rejection Flight Experiment, or SERFI, uses evaporation of water for cooling, and researchers are evaluating the technology's effect on contamination and corrosion of different spacesuit materials. Crew members recently completed several samplings of water to send back to Earth for analysis. This research supports development of spacesuits for future exploration missions. And that's Space to Ground for this week. Thanks for watching. We'll see you next week.
The astronauts and cosmonauts on the International Space Station are spending 6 or so months in an environment where their muscles don't even have to work against the pull of gravity. And as a result, they spend a good bit of time exercising to maintain their overall physical fitness. They have a suite of exercise equipment at their disposal, including a treadmill. In this Speedy Time segment, astronaut Jack Fisher runs through the workout they can get on the Combined Operational Load-Bearing External Resistance Treadmill in the station's Tranquility module.
Hello, and welcome back to Speedy Time. Today we're going to figure out how you get some aerobic exercise on the space station. One way is by running. We have a special treadmill. First off, we got to find it. Where is it? It's on the wall. How cool. We first get a heart rate monitor. Next, we get our super duper harness. Next off, we connect in to the T2 itself. These are very important because they simulate load that we would have on Earth, and they pull us to the treadmill. Otherwise, we'd just float off. We make sure that it's calibrated, and we start. A light jog.
A little higher pace.
We even have a mode called passive. You push it yourself. And then the coolest part of the whole thing is at the end of your workout, it gives you the miles traveled, not just the miles ran. So, using the speed of the space station, 17,500 miles an hour, you can go like, I don't know, 9,000 miles. That's a pretty good run.
Astronauts and cosmonauts on the International Space Station spend some of their time keeping the station operating smoothly, some of their time supporting science operations, and sometimes they help students on Earth learning about science, technology, engineering, and math. In this new demonstrations video, astronauts Megan MacArthur and Shane Kimbrough use the weightless environment on the station to demonstrate the concept of moment of inertia in a way that even I can understand it.
Hello, my name is Megan MacArthur.
My name is Shane Kimbrough. We are living and working aboard the International Space Station orbiting 250 miles above your head. Here on station, we live in a microgravity environment which allows us to experiment with weightlessness and push the boundaries of science.
Today, we will demonstrate moment of inertia by first using a large flashlight, then demonstrating it with the human body. Are you ready? Let's go check it out. Inertia is the tendency of an object to resist change in its current state of motion. That might sound familiar since Newton's first law of motion is also referred to as the law of inertia. Moment of inertia, on the other hand, describes an object's tendency to resist rotational acceleration. An object's moment of inertia is a property that depends on how mass is distributed around its axis of rotation. There is a relationship between an object's mass distribution and how easily it spins or resists spinning. In general, objects have a lower moment of inertia and are easier to spin if the mass is closer to the axis of rotation. As you can see, the flashlight rotating about its longer axis is spinning at a faster rate than the flashlight rotating about its shorter axis. This is because its mass is closer to the axis of rotation. The spinning flashlight in this position has a lower moment of inertia, which means there is less resistance to rotation. When the flashlight is spun about its shorter axis, its mass is spread further away from the axis of rotation. In this position, the flashlight has a higher moment of inertia. Now let's see if this applies to humans as well.
Notice how fast Megan is spinning in relation to her body's position. When her arms are tucked in tightly next to her body, her moment of inertia decreases, which causes her to spin faster. When her arms are extended out, more mass is pulled further away from the axis of rotation, which increases her moment of inertia and causes her to spin slower. This happens because redistributing our mass changes our moment of inertia, which in turn changes how fast we spin. Thanks for coming aboard and watching our demonstration today. To explore more on moment of inertia, check out the Classroom Connection lesson that goes along with this video and discover many other lessons and activities at the STEM on Station website. See you next time.
One major goal of the International Space Station is to get us ready to explore beyond low Earth orbit, as we will do in the next few years as we start to build a sustainable community on the Moon through the Artemis program. Join narrator Drew Barrymore as we learn why returning to the Moon is the next natural step in human exploration, and how the lessons from Artemis will pave the way to Mars and beyond.
We are going. The history of this agency is marked with broken barriers, once viewed as impossible, with science fiction turned reality, with innovations that have spun industries all their own, and with demonstrations of peace for all humankind.
We soar in the skies of our home planet. We maintain a human presence just outside of gravity, and we touch points all across the solar system and beyond. We're going back to the Moon, and this is why.
The moon is a treasure trove of science.
It holds opportunities for us to make discoveries about our home planet, about our sun,
and about our solar system.
The wealth of knowledge to be gleaned from the moon will inspire a new generation of thought and action.
Without fail, every major program and mission NASA has invested in has led to technologies and capabilities that have shaped our culture.
The breakthroughs of the Artemis era will define our generation and the generations to follow.
The tens of thousands of jobs associated with propelling us to the moon today are just the beginning of a lunar economy that will see hundreds of thousands of new jobs develop around the world.
This is not an ambition of one entity or one country. The exploration of the moon is a shared effort,
woven together by a desire for the greater good.
Why the moon? Because the missions of tomorrow will be sparked by the accomplishments of the Artemis generation today.
Because the ambition to go has already begun.
And because Mars is calling. We need to learn what it takes to establish a community on another cosmic shore. So let's camp close before pushing out.
And so, we go to the moon now, not as a series of isolated missions, but to build a community on and around the moon capable of proving how to live on other worlds.
We'll use the lessons from more than 50 years of peaceful exploration to send a new generation to the lunar surface to stay.
We will anchor our efforts on the lunar South Pole to establish the Artemis Base Camp,
positioning us for long-term science and exploration of the lunar surface.
We will prove what it takes to assemble a complex ship in deep space.
We will perfect descending down to and returning from a distant surface.
We will learn how humans can survive and thrive in a partial gravity environment.
With improved spacesuit designs, mobile habitats, and with reconnaissance robots pre-positioning and relocating supplies.
We will learn how to utilize the resources we find on these other worlds, starting with finding water ice and purifying it to drinkable water.
And refining that into hydrogen for fuel and oxygen to breathe.
We will establish fission power plants on the surface of the moon capable of supporting a growing community of efforts.
And we will expand the logistics supply chain
to enable commercial and international partners
to resupply and refuel deep space outposts.
None of this is simple or easy, but nothing in our history ever has been.
The Eagle has landed. You got a bunch of guys about to turn blue. We're breathing again. Thanks a lot.
This kind of continuous lunar presence is a natural extension of all that we've learned in low Earth orbit. And what we will accomplish there will ensure the monumental missions to Mars are within reach. As we ready the launch of the first Artemis mission, and as commercial companies ready their lunar landers for the first private payload deliveries, we have already begun to take the next step.
Part of the science mission of the International Space Station is to take advantage of the weightless environment in low Earth orbit for research on technologies that can benefit future exploration, or life on Earth, or both. For example, the station is home to a 3D printer that can make things and then recycle them and 3D print new things with the same plastic.
The In-Space Refabricator. Presented by Science at NASA. While 3D printers are technology that many people are familiar with, there's one 250 miles above us on the International Space Station, or ISS, that's unlike anything currently found on Earth. It's known as the Refabricator, a hybrid 3D printer that can recycle its hard polymer plastic numerous times to make new items. About the size of a dorm room refrigerator, the device is controlled by operators on Earth who oversee its manufacturing via video cameras. Nikki Werkheiser, NASA's in-space manufacturing manager at Marshall Space Flight Center in Huntsville, Alabama, says recyclers on Earth grind plastic pellets to create their products. But that grinding creates material shear, which prevents you from reusing that plastic again. It's no longer strong enough. For this technology demonstration, the company, Tethers Unlimited, developed a novel recycling process that doesn't require grinding, and that allows us to recycle the plastic multiple times. The ability to reuse the plastic over and over again is essential for long-term space exploration. Werkheiser says, "We can replace a lot of the things we need when we're orbiting above Earth. We just have them delivered on a resupply mission. But when you're in deep space, you don't have that option. You have to have the ability to make all the parts you might need, and without having a large stockpile of extra materials." The refabricator can even recycle plastic items not normally associated with Earthbound 3D printers. For instance, almost all of the materials that are delivered to the station are packed using foam or plastic bags. Both can be loaded into the refabricator to deliver items such as a plastic syringe, an eating utensil, or a custom-made wrench. That ability limits the amount of backup materials you need to take with you on a long-range expedition. After all, in space, space is at a premium. The refabricator's technology demonstration will be composed of 2 phases. During each phase, the refabricator will perform 7 cycles of recycling and printing parts while on board the ISS. All of the items printed by the refabricator will eventually be sent back to Earth for testing and analysis to determine the effects of repeated recycling on the material properties of the plastic. Werkheiser notes, "I'm very excited about this technology both in space and back on Earth. I can envision a day where you go to the grocery store and drop your water bottles and plastic bags into a refabricator, and then select your new phone case, or a kitchen gadget, or the raw filament that you can use in your 3D printer at home." For more science from the International Space Station, go to www.nasa.gov/ISS-science. For more information about how the promise of future exploration is transforming today's technology, visit science.nasa.gov.
It's time for a space riddle. What has 3 eyes and swivels? If you guessed Raven, you're right. If you don't know what Raven is, well, then stay with us for this Tech on Deck episode as NASA's Exploration and In-Space Services Projects Division at the Goddard Space Flight Center explains the technology demonstration payload on the International Space Station that is helping NASA engineers develop an autopilot for spacecraft that may be used in future exploration missions.
Did you know there's a 3-eyed raven currently perched on the International Space Station? Not an actual bird, but rather a technology payload that is helping NASA develop a relative navigation system, or autopilot, for spacecraft. Launched to station in 2017 aboard a SpaceX Dragon on the company's 10th commercial resupply services mission for NASA, and installed on the outside of ISS by station's Dexter robot, Raven is equipped with 3 distinct camera vision systems: visible, infrared, and LiDAR. Combined with NASA-developed software algorithms, this rotating module of technology keeps a weather eye on arriving spacecraft. Raven's head, containing its 3 eyes, or cameras, is always on the swivel, which is made possible by its integral gimbal.
Raven is an on-orbit test bed that was built to mature technologies related to relative navigation sensors and algorithms. Raven was launched to the International Space Station aboard a SpaceX Dragon capsule in February 2017. And it's been operational on the space station since that time. So using 3 different sensors on Raven that are on a movable gimbal platform, Raven can track the incoming visiting vehicle to station all the way from very, very far away, all the way up to where they dock with the space station. So basically, at any given time, Raven can tell you where the incoming visiting vehicle is in space relative to the space station and what attitude or pointing direction it is.
Raven sends the data it collects from tracking and observing incoming spacecraft to its processor or brain, called SpaceCube. This information then tells Raven how it needs to move to continue to track the spacecraft and gauge relative distance and positioning. NASA engineers have taken what they've learned from multiple Raven observations over the years to adjust and fine-tune the relative navigation system as needed, so it's ready for the upcoming on-orbit servicing, assembly, and manufacturing 1 mission, which will robotically refuel a satellite, among other things.
Raven is a sensor system that can image an object, process those images on board in real time with advanced algorithms, then calculate the pose of the object relative to itself.
These factors come together to create something like Spacecraft Autopilot. Much like a self-driving car can maintain cruise control based on the speed of the vehicle it follows, 2 free-flying spacecraft will be able to dock with one another using this technology. Though this operation is similar to the autonomous docking of visiting spacecraft to station, Raven's unique application is necessary for docking 2 satellites with the challenges of each moving and rotating in every direction during the rendezvous and docking phase.
Using that information to then guide the first spacecraft to autonomously rendezvous with and dock with the second spacecraft. So that means finding it in space, aligning with it appropriately, and then bringing the 2 vehicles together without smashing them into and destroying each of them, all without human intervention.
This capability is the kind of thing you need for docking with spacecraft that were not originally designed to be docked with and serviced, which happens to be a vast majority of them. That's why Raven's time on station is critical for the future of on-orbit servicing, assembly, and manufacturing, or OSAM. The OSAM-1 mission will use Raven's relative navigation capability to autonomously, meaning no humans involved, rendezvous and dock with the satellite, and then telerobotically refuel it. This will be the first time in history a spacecraft not originally designed to be serviced will be refueled as a means to extend its operational life. Raven is also important for future exploration missions.
Raven's technologies can be applied to future NASA missions because if humans want to make a footprint in the solar system beyond low Earth orbit, which is where the International Space Station is located, we're going to have to rely on some form of autonomous docking technologies in the future. Whether it be an unmanned cargo vehicle meeting up in orbit around the moon, refueling tankers located in geosynchronous Earth orbit, or a return vehicle arriving on Mars in advance of a crewed landing, all of these feats will require the technology we're developing with Raven.
Using its 3 eyes, Raven is looking to the moon, Mars, and beyond.
Relying on highly robust autonomous systems becomes more crucial the further you move away from Earth as the communications time increases drastically. Once you move past low Earth orbit, it becomes very impossible for humans on Earth to do these highly complex maneuvers in real time. It's more efficient to allow computers to perform these sequences autonomously without human intervention.
Although Raven has successfully concluded its main mission objectives, it remains on station. Meanwhile, its team on the ground is using what they've learned to develop more never-before-seen technologies that will enable future space exploration.
In order to support those future deep space journeys, scientists in NASA's Human Research Program have been trying to figure out what dangers such a long-duration spaceflight poses for human explorers, and how to protect the crews on those future missions. Some of that work is being done on orbit, but some is underway at the NASA Space Radiation Laboratory.
The NASA Space Radiation Laboratory is an outgrowth of Brookhaven National Laboratory's particle accelerator. It utilizes the heavy charged particle radiation beam from various components already existing at Brookhaven Lab to then deliver specific doses, ions, and energies of radiation to the actual NASA Space Radiation Lab itself, with the goal to determine the potential risks to human beings from exposure to radiation during space travel.
The bulk of the radiobiology data that we've collected from the NASA Space Radiation Research Laboratory has really helped us establish our space permissible exposure limits. NASA has a set of limits that helps protect the astronauts not only from the short-term effects of radiation, but also the long-term health effects. In order to establish what those limits should be, we have to understand how space radiation is different than terrestrial radiation. And the experiments at NSRL has helped us establish our permissible exposure limits in terms of protecting the crew from the risk of radiation carcinogenesis, and also setting non-cancer career limits to the brain for central nervous system effects, and also to the heart for cardiovascular disease.
The primary difference with trying to compare what type of radiation dose an astronaut would get on a mission to Mars versus what a person could expect in their day-to-day life over time is that time factor. Now, a mission to Mars, depending on when you go and how the planets are aligned and such, you're still looking at approximately a 2 to 3 year mission. And while that seems like a long time, it's very different than the amount of time that, say, a non-astronaut, just a regular person that has nothing to do with space travel gets over, say, a 70, 80-year lifespan from, say, some radon gas in the home, or from medical tests that are administered where you get a certain amount of dose from CT scans or PET scans and X-rays through the course of life. So you're delivering a certain amount of radiation dose in a more compressed period of time than you would to the person that has never been a space traveler and such. And that's one of the trickiest aspects to trying to determine radiation dose. The same amount of radiation dose delivered in a day is very different than that same dose delivered in 3 years, even though, well, it's the same dose. It's not that simple, and that has to be evaluated when you try to determine the potential risks of absorbing that kind of a dose.
Want another look at any of the stories you saw today? Well, you can find them all on YouTube and Facebook at those addresses right there. They're rubbing shoulders with lots of other great features on a wide variety of NASA topics. If you're looking for good conversation about human spaceflight, check out Houston, We Have a Podcast. It's our weekly show about all aspects of human spaceflight and NASA's missions of exploration. Today, we observed the 60th anniversary of NASA being here in Houston in a talk with John Urey of the Johnson Space Center History Office to recall the arrival of NASA's first landing party in southeast Texas and the development of a scrubby grazing field into the home of human spaceflight in the United States. Go to nasa.gov/podcasts. That's where you'll find this week's episode and all the previous episodes and the full library of all the NASA podcasts, which you can also find on Apple Podcasts, Google Podcasts, and SoundCloud. And you can get the latest from all over NASA delivered to you every week. Go to nasa.gov/subscribe to sign up for the NASA newsletter. You will thank me.